So,
This conference will now be recorded.
oh,
Yeah,
you
sorry,
missed
I
my whole.
forgot to press record earlier.
No,
So
that's
this is being
okay.
recorded.
That's okay.
All right, Karen, sorry about that.
Yeah, no problem. So with that, I would like to just let Steve introduce himself, and then we'll get started.
Yeah, thanks, Todd. So my name's Steve Fick. I'm a colleague of Todd's. I'm also a senior solution consultant, and my background's actually not too far off from Todd's. I worked as a machine designer, though, for a couple of years. So designed some really cool stuff, not quite as tasty as what Weber Grills creates, but fun nonetheless. And then worked for a reseller for almost 10 years and have been with Solidworks now for 6. And I primarily focus on our data management tools, so PDM and Manage and now the Innovia. So if you enjoy geeking out on data, feel free to hit me up. But
Crickets.
yeah, no, I don't see
Sorry,
the chat.
Steve.
I don't see the chat lighting up at the moment, but hey.
Right.
Anyway, yeah, thanks for having us. This should be a lot of fun.
Awesome. Thank you, Steve. What I'm going to do for bandwidth issues is stop sharing my camera. So hope you don't mind. And then I'll join back, obviously via camera once my part is over. So let me turn that off just to make sure that we have good bandwidth for this presentation. Can everybody see my screen? It should say the next technology shift.
Yep.
Okay, awesome. And also I should point out, Steve, you mentioned the chat. If you guys have any questions, feel free to throw that question in the chat and we'll address those as they come through. And we can also address them live, so don't hesitate to do that. This is definitely informal, so please ask questions. But what I want to do before we get into any sort of like live demonstration here is talk a little bit about what is 3D experience. I'm sure you've seen our marketing. You have to have seen our marketing unless all of it goes directly to your trash. But even then, you've probably seen something at least on our website. But 3D Experience Platform, really at Dassault Systems, who is our parent company, they've developed what we call the 3D Experience Platform. So let's talk about why, where, how, what does that really mean? The first thing that we want to look at is, well, where did we come from? And if you recall, those of you that are what do you want to call it, senior, I guess, senior designers or engineers, CAD users, prior to SolidWorks being released into the market, and this is US dollars, I assume euros are relatively the same, one CAD station would cost, one CAD user would cost almost $60,000 to run a CAD system. And that's a $40,000 Unix workstation with a seat of 3D CAD at the time, which was running, let's say, approximately $20,000. If you think about that, it's insane. It's just a ton of money and what customers were investing in and what it costs just to be a 3D designer. And then lo and behold, SolidWorks came in 1995, just after Windows 95 was released and obviously built on the Windows platform and really changed the market and changed the availability of 3D for everyday designers. $60,000 weren't in too many companies' budgets back then. So for SolidWorks to come out at a price point of $39.95 back in 1995 and being able to run on basically a PC running Windows was really unheard of. And it really, as you probably know if you were around back then, just completely changed the market altogether. From a pricing standpoint and a usability standpoint, not to mention the difficulty and the challenges of learning the systems that were available back then. Move forward to 2020 and SolidWorks has expanded greatly. Not only do we do 3D modeling that we originally had back in 1995, but then we've enhanced, of course, all of the features dramatically since 1995. If you ever get a chance to run on a virtual machine an old seat of SolidWorks 95 or 96, it's quite amazing. Matter of fact, one of our resellers here up in Wisconsin did that at one of their release what's new user sessions about 2 years ago, and they had a simple part that you had to run through and try to design in SolidWorks 96, I think it was. And I would say less than 10% out of all the people that tried it were actually able to complete it. just because of all of the user interface and all the changes and things that we got used to. Anyway, I digress a bit. Now we have a whole slew of products. Steve mentioned a few minutes ago that he specializes in PDM and manage. Those are a couple of products. We have electrical, we've got PCB, we've got all of these different products that we've been able to add over the years. Now let's take a step back and let's talk about, I mentioned Dassault Systems. You may or may not be familiar with that name. Dassault Systems is the parent company of Solidworks. Solidworks, the brand, was acquired, I believe it was in '97. If I'm mistaken, Steve, please correct me, but I believe it was in '97. Dassault Systems acquired Solidworks, and we're one of many, many different brands that are available underneath the Dassault Systems umbrella. Up until a handful of years ago, all of these different brands operated very independent of each other, which at the time worked okay. But one of the challenges with that is that we should all be able to work together. And why wouldn't you want us all to work together? So for example, you've got CATIA. Most of you have probably heard of CATIA. You know, companies like Boeing use CATIA for airplane design. They use tools like Simulia with advanced simulation to do very advanced simulations above and beyond what SolidWorks simulation suite of products can do today. There's a pretty cool video. Another Simulia product is doing airstream analysis around a bird. Pretty cool stuff. You're not going to be able to do that in SolidWorks Flow. We have our Biovia brand under Dassault that does biological things like that Living Heart project. One of our first products, and we'll see this here in just a few minutes, that we developed purely on the 3D Experience platform is XDesign, which is also or falls underneath our 3D Creator role, as we call it. We built this from scratch on the 3D Experience platform developed by Dassault Systems, which really enabled us to start from scratch on a new and upcoming CAD product that can help complement SolidWorks as you use it today, but it's built on the cloud and browser based. So, you know, one of the probably the biggest enhancement requests that we've heard over the years was, you know, can you get SolidWorks to run on an Apple or a Mac? And of course, being built for 25 years on the Windows platform, that's just unfortunately nearly impossible to do, if not impossible to do. It would take years and it would just probably never meet our customers' expectations. But now being able to develop purely cloud-based CAD products on the platform within a browser, you can now have access to 3D CAD design really anywhere from any device. So if it's a Mac, if it's an iPad, if it's an Android device, it's really irrelevant. You can run from that browser and do 3D design. Not only that, but it also opened up doors for new technology that we can develop new products on at SolidWorks. So what you're seeing here is X-Shape, which you're going to see in a little bit. Steve's going to show you a little bit of X-Shape, but this is using subdivisional modeling. This is just something that we were not able to develop for SolidWorks Desktop. But again, building a brand new product on a new platform opened up the doors to be able to do that. Again, like I mentioned earlier, it's browser-based, so it allows you to access your data on a browser. So even if you're not a CAD designer, you might want to be able to access that data. You might want to manage projects. All of this without having a local install. Again, you can be sitting at the airport, you could be sitting on your couch and being able to do markups, be able to view 3D models very easily, very quickly. You not have to install anything like an eDrawings type app. You would just have direct access to the latest and greatest data. And additionally, you'd be able to share all that data on the web. And again, access all of that data with any device, anytime, anywhere. I would love to be the person on the far right, to be honest with you. Right now would be great, but I'm not. So what does all this mean? Well, if we take that and we take a look at the 3D Experience platform, it ties all of the different applications and all the different brands together. So now we can use SolidWorks data inside of Simulia for advanced simulations. We can use SolidWorks data inside of Delmia for advanced manufacturing. etc. And you see all the different brands, and underneath all of those brands means our customers have access to all kinds of new technology that really, without having a common platform, was either challenging or impossible to do before. If you were to purchase, let's say, advanced simulation for whatever your company does, you needed something beyond the capabilities of SolidWorks simulation. You'd be doing an import and an export to get your data over into Simulia, and same for like Delmia for advanced manufacturing. So the platform ties all of this stuff together on one common, easily accessible platform. As we take a step forward, we look at today, again, believe it or not, last year in 2019, we surpassed the $1 billion revenue mark, which is phenomenal. That's just SolidWorks as a big piece of Dassault Systems' overall revenue numbers. 5 million plus global users and 250,000 commercial customers. I mean, it's just amazing what's been accomplished in the last 25 years. And obviously a lot of this is attributable to customers just like yourselves that are greatly appreciated. And hopefully, we have just such a passionate user network. It's pretty awesome. It's awesome to see. So moving forward into the future, 2020 and beyond, as we plug into the 3D Experience platform, all of these different applications from all the different brands are going to work more seamlessly together than ever before, and really be more of a partner with those different brands instead of competitors or very independent of each other. Okay. So with that said, Steve, did I miss anything there that I should have mentioned?
No, I think you nailed it. You did.
Okay, so here's what I'm going to do. I'm actually going to close that. Let's just start from scratch. Obviously, I have SolidWorks, just like probably all of you that are on the call also have SolidWorks. But how do we access the platform? And again, it's a web browser. So in this case, I've got Google Chrome that I use. I've got a few tabs that fire up automatically. But let's just pretend for a moment I'm on my iPad. I'm on my Mac. It doesn't matter. I log into the platform and I'm able to have direct access immediately to all of my data. I can see the different files that are located in my different workspaces. I can view any of these. So let's say, for example, I wanted to view this assembly. I just drag it over and you'll see that the performance is pretty darn quick. Loads up my assembly. I can view it, do things like zoom, of course. All this without installing anything, which is probably one of the most phenomenal parts about it, is I don't have to install. I can just directly view my data. Because it's an assembly, I don't have to actually have an exploded assembly view built into it. I can just use the automatic explode tools. If I wanted to dissect it a little bit, I can do things like measure, section tool, and markup. And again, the key point here is that it's all within the browser. I don't have to install anything. Another aspect of the platform is what we call communities. And communities are private communication spaces, I guess, that you can have for different projects, for different functional teams, where you want to be able to share information within each other. So here I've got a community set up for this particular project, which is working on this BioDapt leg. I can scroll through here and I can see all the different communication that has occurred up to this point. Very first created the community, some different links that were put in here about the project as we're kicking off this project. We could see that my colleague Michelle had created a post that we just have a couple more things that we need to complete. My other colleague Tandy actually identified using simulation that there was too much deflection happening over in this lower area that we need to take a look at. Again, if I want to, I can manipulate the model, take a look to see where they're talking about. And I can see, okay, it's this part of this upper subassembly here. And what we want to do is redesign and incorporate into the lower bracket. And that's kind of where my design kicks off here, where we want to start working inside of SolidWorks. Now, of course, there's a lot more to the platform itself than these three things that I just showed you, but just from a high level standpoint, some of the core functionalities of the platform. The very last and latest is a post from actually one of our, well, it's from me, but we're going to pretend for a moment that it's from one of our outside vendors, where they actually created and started that design and created the part in drawing and saved it to our 3D drive. 3D drive is analogous and very similar to Google Drive you might be using, or OneDrive, where you can share data in that sort of format, where you can share a folder, have people upload or download files from that folder and share those files. Now, just like Google Drive or OneDrive, it's not really revision based, and it's not your traditional like a PDM. It's not a data management system. It's simply a methodology to be able to share data. So from here, I can just grab that whole project folder and I can download it if I'd like to. Matter of fact, I could view that data in that same 3D Play app that we saw just a moment ago. In this case, I want to download all the contents with their subfolders. And for the sake of time and not downloading it, I'm just going to hit cancel. But what ultimately will happen is it will download those files wherever you tell it to save it to, and not templates. What am I looking for here? Let's go there. Project files. Download a zip file. I extract those zip files, and I can see I have the part and drawing, and those are located on my desktop. So these are not being managed by any sort of PDM at this point. Okay, good. So I downloaded those files. I've got the files from the contractor that did the work for me. So what I want to do is get working. Now, because Solidworks and the 3D Experience platform work together, even though I'm in a browser, I can actually grab the assembly that I want to work on and just simply drag it in and drag it into my SolidWorks window. So let me go ahead and do that. Minimize this. And for this portion, we see we have two sub-assemblies. I actually only want to work on one of those sub-assemblies. So I'm going to open up this top portion because that's where that bracket is located. And let's jump over here and just close this one out for now. So, okay, so if we just take a quick examination of where we're going here, this is the bracket we want redesigned. We want to strengthen this area, this whole area where this pin is located, so that we have less deflection. This is the attachment point where it actually attaches to the foot. So I need to make sure that that's taken into account. Now let's go ahead and open up that vendor's file. So I'm just going to go to your traditional open, just like you guys are used to every day. Go into that same folder I showed you a moment ago, and I'm going to open both the part and the drawing. And now we've got those three files open. So we've got both of those open. One of the things I want to point out is that, let me go ahead and maximize this just for a moment, is that these files, now they're still on my hard drive, but they're not on the platform. So they're not revision managed, they're not lifecycle managed, and probably the most important part from a collaboration standpoint, they're not accessible to my other coworkers at this time. So one of the first things that I want to do is put these on the platform. So I'm just going to go inside of my task pane, save those files. Oops, give me 1 second. It looks like I already have those in there. Let me do that again. Sorry about that. So what it's going to do is, first of all, it's going to put it into my local cache. If any of you use PDM, you're familiar with having a local cache, and that's where you actively work on your data. And obviously that's for performance reasons. You're not working live per se. You're connected obviously to the platform or to your PDM system if you use SolidWorks PDM, but you're actually opening and using those files directly off your hard drive for performance purposes. So the first thing it's going to do here is copy those into my local directory from my desktop, because they need to be located in there so that I can put them up on the platform. Now, once that's completed, I can see here that the file that I have locally is the same as what I have up on the platform. So this is basically telling me that it's the same as in my PDM system. If this was to change, if you're thinking about collaboration, then I'd get a different symbol here indicating to me that that something has changed. Now, if we take a look at these side by side, let's just tile these. You'll notice that this part over here is this special mounting area, and this part, the other person neglected to actually put that in there. So I need to do that work for them. Now I could come through and take some measurements, and I could essentially rebuild those features. But instead of doing that, I like to take shortcuts whenever possible, because I am extremely efficient. Just tell my manager that. And what we'll do is just tile these windows, and I'm going to borrow those features that created that. And to do that, and you're probably already familiar with this, but to do that, I can simply grab those from one part just by control selecting them, drag them over to the other part, and drop it. Now, when these features are developed, they have relationships to either edges or whatnot within that part. It's asking me, what do I want to do with those relationships? I can delete them or leave them dangle. And I'm going to leave them dangle, meaning the relationship's still going to be there. It's just not sure where to point that relationship to. Let me close that, and let's take a closer look. So if we jump into the sketch for this feature, it might be kind of hard to see. If you have good eyes and you're not colorblind like me, you can probably see that this little end point is actually a brownish color. That's one way that you can see that something is a reference is dangling, is that brownish color. What I like to do though is I like to use display delete relations. And within here, if I look through the different relationships inside of this sketch, I can also see that there's a midpoint relationship that is dangling. Now, some of your sketches might be a bit more complex than this. So another way to do this is you can filter. All I want to see is the dangling. All I want to see is overdefined, external, etc. I can also just filter that. That'd be an easy way to find that particular relationship. So let me go normal 2 just to take a look on here. Now I can delete it and I can re-add a new relationship, but what's been around for a long time and a lot of people don't know about is you can just grab that brownish color and you can drop it on where you want that new relationship to be. So I just dragged it, dropped it right on that edge. It's a midpoint relationship. It turns black, so now that is fully defined. So that's pretty easy. I was able to basically copy and paste that feature from one part to the next. So that means I got a little bit of work to do, at least on this drawing. So let's take a look at the drawing here for a moment. Probably want to add some center marks, so I'm just going to use my center mark tool to add a center mark to that top view. And on this side view, we'll add a center line and just the selected view. And I'll probably want to add a section view just to get a little bit more clarity. So to do a section view, we'll just use the section view tool and drag that guy over here. Now that I have those, just want to rearrange, give myself some space. And of course, I'll need to add some dimensions. So another tool that I like to use is the insert model items. If you have more complex parts, sometimes people don't like to use insert model items because it's going to take all the dimensions from the part and throw them on your drawing. And for complex parts, that can be a little bit overwhelming. So one methodology to simplify that is, as you're going through and detailing your drawing, you can do it by selected feature and simply insert the dimensions and annotations that already exist for a selected feature one at a time. In this case, I'm going to say entire model. So what it's going to do is add any dimensions that I have on my model that don't currently exist. So it's not going to duplicate anything. It's just going to add the ones that don't exist. And maybe with a little bit of cleanup, we'll be good to go here pretty quick. Take a look at my top view. And let's just throw a quick center dimension on here. And that looks pretty good. All right, how's everybody doing? Does anybody have any questions so far?
That auto dimension thing would have saved me hours in university.
I know, it's kind of a cheat, isn't it? Yeah. Awesome. Anybody else, or we're good to go?
We're good in the comments, Todd.
Okay. Okay, great. So the next thing that I want to do, of course, I've made changes to this. We'll notice that my task pane, again, this is kind of a look into my vault, if you will. This is looking at the platform. It's comparing the files to my local hard drive, and it's telling me if I hover over this that the file has been modified. So I just need to click save. It's going to go take a look at those files. It's going to tell me that it's modified but not reserved, so changes will not be propagated. So the idea of reserve is that when you're working on something, you generally want to reserve it, or you would reserve it so that nobody else can work on the same thing at the same time. Now, it's not currently reserved by anybody, so we actually put a little button right in this save box that says reserve modified files. It's going to go ahead and look at all those modified files, automatically reserve them for me without having to bounce back between the other dialog box. It's very helpful to have that. I'll go ahead and save this. Notice I get the green check marks. I also have this green key, and that indicates that it's reserved. If by chance, let's say Steve had one of these open, I would see a red key, and it would tell me that it's reserved by Steve. So that's very helpful information, especially when you're collaborating, especially these days when people aren't sitting in the office right next to each other and they can't look over the cubicle wall or walk over to the next office and say, hey, Steve. Or better yet, let's scream across the office and say, who's working on, on my part? All right, so I got that part fixed up. Let's get back to our design work here in our assembly. And the next thing that I want to do is get rid of the old design stuff. So to do that, I'm just going to Windows select and delete. Yep, I should hit yes to all. And let's delete the old bracket there. Okay. Another nice little shortcut that I like to use is smart mating when you're adding a part all in one step. So to do that, it's pretty simple. If I pick a cylindrical face and drag my part, it'll give me a concentric relationship. If I grab a flat face, drag it, point it to a flat face, it'll give me a coincident relationship. If I grab this edge, it'll actually give me both at the same time, which is very, very handy. Especially if you do a lot of fasteners, this can really help. But I'm just going to drag it. Don't have to hold any shortcut keys. Point it to a reference edge, and it'll snap right into place. Pretty easy. So right there, I just got a concentric and a coincident relationship. I don't need to work on this part anymore, so I'm just going to close it. And let's get back into this design here. Now, it only added a concentric and a coincident, so it still rotates. And because I deleted those other parts, my shock is still floating around. So I need to add some more mates. Let's just move this block down. Now, in this case, I do use the Alt shortcut key. So once the part is in your assembly, to use Smart Mates, you hold the Alt key, drag and drop. And I want a concentric. That looks pretty good. And if we take a look back here, I no longer have a fastener, so I need to add a fastener. So to do that, I'm going to go to the platform. Let's drag that just a little bit over. And I'm going to do a search. And in this case, I'm going to look for a shoulder screw. Obviously, I've searched for it before, but I would search for M6 or whatever information that you know about it. Click on the search. Give it a moment. So right now, it's reaching out to the platform. It's looking at the cloud, if you will. and it's looking for those keywords, and I found 2 of them. I've got a low profile and just a regular. I'll go ahead and grab the regular one, drag that into my assembly, and I'm done searching. So we're good with that. Again, I can't say enough about SmartMates. I'm going to hold the Alt key, grab an edge, and I'm going to point it over here to this edge over here. And that, again, is going to give me a concentric and a coincident all in one shot. That looks pretty good. Hold Alt, click and drag and drop to get my other SmartMate. And now I've got this component in place. So SmartMates, if you're not using them, are extremely handy. Okay, so there's obviously a drawing for this. So what I'm going to do is just do a quick search again, and I'm going to look for the drawing because I need to update the assembly drawing. And here we see the drawing. Drag it up to open it. And we'll watch that the components are going to update as you would expect. The only problem is we've got some missing balloon references, of course. It was pointing to a different part. So now I get that dangling color, just like we saw inside of the sketch, and a question mark indicating that it's not sure what it should be pointing at. So I'm just going to basically drag it off and reattach it to the edge of this component and reattach it to the edge of that component. We'll see my bill of material updated as you would expect. And we're good to go. All right, so that was pretty easy. Let's get back to the platform. And what I want to do is save this. Now, one of the things that could be, or is a challenge right now for me is that, let's go ahead and hit save. It's going to take a moment because it's looking at my my Fastener library. So just give me a second here. And I guess while it's doing that, we'll take a look at what other information we see here. We see the revision. We see which files are in my notifications. So you always get notifications. In this case, I actually have licenses expiring. We see the status. We see who's got what reserved. We see that I have that 17900 reserved. That was that component that I created. And we see the maturity state. Now, these components and that top level end assemblies, there's a sub-assembly and top level assembly are already released. What that means is I can't do anything with it. I'm an engineer. That's already released. And you wouldn't want somebody coming in and just modifying released data. So instead of just being able to save that, I'm going to have to bump the revision on that drawing, the top level assembly, as well as that sub-assembly. I'm going to give it a revision comment and just say, added new bracket. And now because I'm bumping the revision, I'll be able to do this one too. Edit those two and that one. Okay. Added new bracket. Go ahead and save. And so through this process, it's creating a new revision of the files that I've changed and saving that data up to the cloud. Now keep in mind when you go back to anybody that has that browser open, be it a manager or be it other engineers, all of this data, now that it's pushed to the cloud, no matter where they're at in the world, they have access to this latest and greatest data. Okay, so let's go ahead and close that down, and let's close that down. One other aspect of the platform is the ability to create and even assign tasks. And think of this kind of as your to-do list. I can access this information in my browser, or I can access this information right inside of Solidworks. And since I'm in Solidworks, I'll just go ahead and go to my task app. And in here, we see that there's a couple of tasks that myself and Steve need to do. As a matter of fact, I can take a look, and I can take a look deeper into my tasks. So this finish 4-bar linkage, I'm just going to go ahead and hit edit. And inside of here, I find the information for that task. So let me just spread this over a little bit more. It says add the attached link that was created in XDesign to the VF2 foot assembly. Also try to remove some material to the link to make it lighter. The assignees are myself and Steve, and we see 2 attachments. And I don't particularly like the way that we have this termed attachments, to be honest with you. And the reason for that is when we think attachments in general, we think of emails. You attach things to an email. And if I attach these 2 files to an email and say I email them over to Steve, now I've got 2 of each of those files, right? You've got the 2 that I have on my desktop or wherever, and then I email them, and now I've got 2 more that Steve has. And then Steve wants to collaborate with somebody, and he emails those again. Now all of a sudden you've got 6, and you can imagine very quickly you run into quite the data conundrum. These attachments aren't really attachments, they're actually just references. Because these files are on the platform, these are just references to the actual original files. So I can open them directly from the platform. Let me go ahead and open this VF2 foot. And let me go ahead and open the link. And these are opening the actual original files. Again, these are not copies that were put here like an email would do. They're actually references to the actual files, again, inside of my data repository. And since I'm working on it, I'm just going to change that to in work. That way, anybody involved knows that I'm working on this. Let me go ahead and tile my windows because I want to add this link over to this assembly. Again, I like to use SmartMates if I haven't hounded on that enough. When you SmartMate, tab flips the alignment. So I'm just hitting the tab key so I get the proper alignment. And we need to add one more mate here. So let me, again, SmartMate one face to the next. And if I want to actually show motion at this point, I'll have to change this subassembly to flexible. And also because I've talked enough about mating so far, I think we can just go ahead and show some components that I've previously mated to this assembly just for complete purposes. And I'll change this subassembly to flexible. And that would be used, of course, just to verify that my mechanism works. And I usually like to turn those back to rigid when I'm done with them. It's kind of a good practice, you know, when if you're working with a lot of sub-assemblies and you want to check motion, I generally like to make them flexible, make the movements, make my verifications as needed, and then put them back to rigid. Now that this assembly is done, I'm going to go ahead and save this assembly, and I want Steve to make some changes. So what that means is because I have it reserved, I want to release the reservation. I don't want to own it anymore. That's so that Steve will be able to actually make modifications to this assembly. So I'm going to go ahead and save that. And we'll notice, even though it's still open and I saved it, I no longer have reservation on it. In other words, I don't quote unquote own it, I guess. Now that that's complete, I'm going to close this foot down, close that link, go back over to my tasks that we looked at a moment ago. And if we recall, there was 2 steps to this task. The first was to attach the link, which I just did. And then it also says, try to remove some material. Now this link part was actually done in the browser in XDesign. Actually, Steve did it. So because of that, and let's say I don't have XDesign, but Steve does, I want to let him know that even though I'm working on this, he needs to finish this task. So kind of like you would do is tag him and say @Steve, please, let's say remove material from link, and then hit send. Now when I do this, it's going to give him a notification in his notification bar. He has some work to do. So with that, if there aren't any questions, we can switch over to Steve, unless there's any questions that I need to cover. How's everybody doing?
Actually, I wrote in the comment section chat, the attachment actually it means it gives a link to the files in the cloud, right?
Yes, yes, correct. Yep. Okay, maybe Kirby, you maybe switch over to Steve.
Steve, you're present now.
All right, perfect. Let me share my screen. All right, you guys should be seeing my web browser, same dashboard that Todd was using earlier. You guys seen that okay?
Yes.
All right, great. So yeah, so part of the fun of this presentation is that Todd and I are working on the same design. He's in, as you mentioned earlier, in Minneapolis. I'm located 2 hours outside of Chicago. So we're in completely different parts of the US, but we can work on things together. I personally like using the web for a lot of what I do. You know, many of us are getting accustomed to that. And the platform is nice because at this point, you'll notice that I have a notification here. So you can see that I can see Todd mentioned me in the his comment on this file, and so it's going to bring that up, and I can review the whatever comments that he's made on that component. I can also see, I can preview what he's done. So obviously we started out without a link on this. A simple refresh of the previewer gives me a sense of the work he's done, right? So simple refresh of the previewer, I can say, oh, that's the link he added to this design. Now, if I switch over on my dashboard, I can have different tabs. So for instance, if we switch over to XDesign, XDesign is our parametric based modeling tool that is web-based, right? So at this point now, I've got the same access to the to-dos and the tasks, just like Todd had. I'm just doing it through my web browser at this point. So if I look at the task that Todd has in work, I can pull that task up. And I got the same access to the attachments he had. So I need to work on this link. So same idea. I'm just going to drag and drop the link right into XDesign so that I can start to work on it. Now, what's neat about this is that with XDesign, many of the same capabilities, things that we're familiar with inside of Solidworks, are available inside of XDesign. So this is, I've got a full feature tree, so design methodology is very much the same. Shortcut context, by just selecting a face, I can come in and say I want to start a sketch. And I should mention too that the way these dashboards are set up, you can think of them a lot almost like your desktop. So if you're running a program on your computer desktop, what do? You maximize it, right? Same idea with design tools on a dashboard and really any tool. If I'm gonna focus in on it, I can maximize it, and that'll take up the full area, right? It has my full attention. So at this point now, I'm sketching on that face, and many of the same things that you're used to doing, right? If I want to pick an edge and convert it, I can do that. Pull the endpoint off because I don't maybe necessarily need it to go all the way around. We all love the S key, at least I personally do. It was probably one of my favorite enhancements, and even to this day still is, the ability to access common commands right by hitting the S key. I'm just gonna draw a straight line over. I get my inferencing line off the origin, which is great. And then I'm gonna just transition this to be a construction line. Right. So with that transitioned, I'm just gonna box select around these entities, and we're gonna mirror it to the other side. So a lot of the things that we're really used to still hold true inside of XDesign. different platform, different design tool, but those things that we're familiar with are there. I'm gonna add a dimension, so we're gonna make this from here to here. Let's make that 14. So that looks good. You'll notice that I'm still getting the blue and the black lines, so we all love fully defined sketches. Here I'm just gonna simply make these two things coincident with each other so that I get a fully defined sketch. All right, so at this point then, let's turn it into a feature. Now, a lot of you guys, I'm sure, are very experienced SolidWorks users, and you never do this, but I inevitably will, from time to time, pick the wrong feature, right? I'll get in too big of a hurry and I'll hit extrude when I really meant to do a cut. Or I get into a feature and I pick a revolve, and it turns out that I actually needed a sweep, or vice versa. So one of the really neat things about X design is that features are what we call super features. It's kind of a weird name, but you start to see what you can do with them. It's pretty cool. So I can take an extrude and I can turn it automatically into a revolve, or I can turn it into a sweep. Okay, and I can do this when I'm creating the feature, or I can do it after the fact. So if you suddenly realize that you've got to tweak it or do something differently, you can always come back in, edit the feature from the feature manager, and you can change it. Not only can I change the type of feature, I can control whether it's I'm adding material or I'm cutting material, right? So in this case, I'm gonna do a cut, we'll do a thin cut, through all, both, right? Something like that. I'm gonna make sure my arrow is pointing down so it gets rid of material, and then we'll say okay, and it removes that material. All right, so pretty cool, and just even more so when you start to think about the fact that I'm doing it inside of I'm doing this all inside of a web browser. I want to add some fillets, right? So we're all used to smart selections inside of SolidWorks. So I can come in here and start my fillet. Right here, I'm going to choose my selection toolbar, and I can, basically have control over having it pick like edges that I might want to use. And then when I'm happy, I'll just go ahead and say okay. All right, so that looks good. Let me back up. I don't think I grabbed all that I needed. So again, feature manager, just come in, delete what it is I don't need. Let's try this one more time here. So we'll grab this edge, fillet. So there we go, and hit OK. Now, the other thing then I can do is take advantage of tangent propagation, right? So if I want to chamfer these edges, easy enough. Tangent propagation takes care of that. We'll pick this edge here. That way it's got both. All right, so that looks good, right? So we've lightened the load. I'm gonna say that portion of our task is done. So we can save this, and we're off and running. Again, same idea with the tasks. Now I can come in and say, well, let's go ahead and move this task to be completed, right? So I can just drag this over here, and we'll say completed. Right, it's a good feeling, right, to mark things off. Now, the other thing is that when I look at the task, now Todd didn't have this task, but I have this one for creating a cover using X-shape. So I'm going to toggle over to X-shape. X-shape is, X-shape is the tool that we utilize to do more organic designs and shapes. So very different mindset for many of us who are used to SolidWorks. But again, let's say my manager was nice enough to give me some context with assigning me the assembly that I needed. So that's handy. I get a full, nice clear view that all that work that Todd did inside of SolidWorks, I can see that he mastered all of that. My assembly is updated. Right, so you're starting to see this kind of back and forth. Not only am I working on the assembly that Todd started, changes I'm making are affecting the assembly that he had. And so we want to create a really nice cover for the outside of this this orthotic. So what I'm going to do is let's start by just simply inserting a new component. So I'm just going to call this foot cover. All right. So we'll call this foot cover, and just like normal SolidWorks, if I want to design in context of the assembly, I can do that. Right? So we're going to do this right in the context of the assembly where I can get a lot of good insight to what's going on. And we're going to utilize what's called subdivision modeling. Now, subdivision modeling, as I mentioned, might be slightly different for a different mindset for some of you. Others that may end up being quite comfortable. But the idea is that you're basically throwing let's just call it a lump of clay into the environment, and then you're able to start pushing and pulling it. Now, quick tip, if you happen to play with this or utilize it, the tab key will alternate where your where your initial geometry goes, right? So I want to center this, but I can hit my tab key and it'll toggle where that ends up. And then I can control the number of subdivisions that take place in the model. So let me bump this one up. Let's toggle this one down. Actually, I always get these slightly backwards. So let's do 3 there. Is it this one? No. There we go. Right. So that's looking pretty good for what we want. So I'm controlling the number of subdivisions that are happening there, and when I'm happy with that, I can go ahead and we'll go ahead and accept it. Now there's some symmetry that I want to start out with here. So to kick things off, I'm going to turn on symmetry. That way, whatever I do, as you would imagine, on the left is going to also work on the right. So it's almost like a real-time mirror that starts to take place. So another quick tip here, if you hold down Control and then you double click on a series, it'll select all the edges along that series. We're going to grab this guy and this guy. And then we're going to do what's called a crease. So crease takes this and provides some hard edges to it, right? Wherever we've selected. So that starts to look pretty good. Let's orient this around. Maybe we let's take these items, and we're going to use what's called the triad, or we actually call it the robot. We can align it to a certain selection, and then once we've got that, you can start to move these back. So let's move these items back this way. So that's looking pretty good. Maybe we'll take the top nodes and we'll just pull those up like so. So it looks pretty good. I can rotate these around. So if I want to start to really kind of manipulate that, I can. But one of my favorite ways to do this is by just simply aligning based on what I sketch. All right. So with my mouse, what I'm going to do is I'm just going to simply draw the contour that I'm interested in having. Right. Something like that. And when I let off my mouse, it automatically maps the shape of my geometry to that contour that I just freehanded, right? It's really quite cool when it comes to just getting some conceptual ideas onto this design. Now, one more thing before we turn off our mirroring, let's just skinny this up a little bit. So that's looking pretty good. And then let's have a little bit of fun, right? So if we come in here and just start to pull this out a little bit, let's grab this guy. We can pull it out a little bit or start matching the contour of the footbed. Let's give ourselves a little bit more coverage this way. And we can grab these and let's pull these guys out like this. Maybe neck these in a little bit, right? Something like that. And maybe we give it a little bit more of a point this way, right? Something like that. So nothing too crazy, but the idea is that if you think about where we started, just kind of this chunk of clay that we threw out there, and you start to think about even in the simple example, the guide curves you would have needed to construct, just the constraints that typically come along with doing this in parametrics, you can start to conceptual ideas actually quite quickly with X-shape. Now, the other thing that becomes very cool about this is that we've still got the same kind of analysis that we love inside of Solidworks, right? So most of the time when you're going to do this, it's going to be a plastic part, and so we need to make sure that we've got our draft angles right. So we can do that. We'll flip this the other direction. Those colors stay live, which is handy because now I can come in and I can select these guys, these nodes right here. So, and once I've got those selected, I can start to just push this in a little bit till that draft angle shows green. Do the same thing over here, select the nodes that we want to manipulate, and just simply move them in until we get the draft angle to be, whatever it is that we're looking for. And we can turn it off. And then as you would expect then as well, if we wouldn't necessarily want this to be just a solid chunk of plastic, so we can come in and do a shell as well. So we'll pick this face, we'll make sure tangent propagation is turned on, we'll flip the thickness to the outside and hit OK. Right, so now we've got this this very nice shelled cover that that looks quite nice on our foot. So here's the other thing, right? We've done some nice work on this. Todd did a great job of adding the link that was requested. I did my best to try and create some nice swoopy designs for the footbed cover. There's this kind of social collaboration piece of this that comes into play with the platform now as well, in the sense that I can take this, I can take my design and I can post it to that same community that we looked at earlier. So the ability to come in and make this available to, I always forget where this is, to my platform community. Right, so I can share this as a picture, and I can say, I want to make everybody aware that. Let's grab our the right community. Right, so this is going to go into the BioDAP community that you saw earlier. I can say, new design ideas. Let me know your feedback. Right? And then we can go ahead and publish this, right? So I'm right from within inside of the design tool. I'm very quickly able to update everybody in the community, right? So when they look at their, feed, my post from what I just did is now available. Anybody that's previewing this design now, right, when they refresh their preview sees that. And this is all just quite nice because I get I didn't save the assembly yet. That's that's why the footbed's not there. But you think about how much happens through email. This is a really great way to kind of shorten that communication. We all use LinkedIn and Facebook, and there's elements of that that are really efficient, and we get to apply them to engineering now with the platform. So that's it, Todd. I think we did a pretty good job of completing our tasks. Any questions from the guys on X Design or X Shape, guys and gals?
Again, with that, like the amount of time I would have saved in university doing models and assemblies, quickmates is beautiful.
Yeah. No. All right.
Nice job, Steve. Thank you.
Thank you very much.
Yeah, that was cool. Thanks, guys.
Especially
no
the
worries.
draft modification. It was wonderful for me.
Yeah, right.
So easy, extremely easy. I think Dan has also the same problem. He's producing molds, I think. I saw him always from LinkedIn. He has the draft problem also. I am designing for foundry industry and modifying a faces drafts in this kind of easy way. It was wonderful to see.
Great.
Yeah, I really like that it's dynamic and you can make changes and see instant results. I think that's pretty neat. Cool. Well, thanks everybody. We really appreciate you allowing us to show this overview to you. Now I'm looking forward to the roller coaster journey here, the real stuff.
All right. Would you want me to get going then?
Yes.
Can everyone hear me okay and see my screen?
Ready?
Yeah, sounds great.
Yeah, I can see it all right.
All right. Well, thank you guys for going through the 3D experience. And thank you, Kirby, for inviting me to present today. So I really appreciate that. I wasn't really sure what to go over, so I'm going to go and throw a lot at you. And most of it's either pictures or videos and just kind of explain what I do and the work that I do with Solidworks, specifically on roller coaster model design. So with that, I will get going here. So a little bit about me. Professionally, I work for the Ford Motor Company. I'm working in fuel metering, in engine systems, specifically for the 2-liter and the 2.3-liter GTDI engine system. And even with that as my full-time obligation, I do manage a 3D printing lab within our powertrain building. So we have over 6 3D printers that we're constantly 3D printing parts that the engineers are designing for our products. As hobbies, I obviously love 3D printing, laser cutting, and CNC milling. Pretty much anything that you can find at a makerspace, I love doing on the side. I'm a part of a makerspace within Detroit. And as far as education goes, I graduated from Purdue with a bachelor's and master's in engineering. I also have a minor in computer graphic technology, which is 4 years of only learning CATIA. So, woo, CATIA is cool. Although the funny story is when I got to my senior design project, they were like, you need to design, your senior design project in CAD. I'm like, cool, well, I've been doing CATIA for like 4 years. And they're like, nope, you're going to use SolidWorks. And I was like, what? I don't know SolidWorks, but I picked it up really quick. So, once you know one, you kind of know them all. So that was a lot of fun. This is me actually at Purdue at the engineering fountain when I was 4. And then here's me when I graduated. So that's a fun little picture there.
Yeah, that's awesome.
So yeah, this is kind of just about all of my roller coaster journey. I created Print My Ride Detroit as like a hobby space, an Instagram account, a YouTube account showing design work, fabrication work, anything that I do revolving around the roller coaster universe. I kind of post and just talk about everything I'm doing. So it's been a lot of fun, and I just wanted to share that experience with everyone. So it all started in my parents' basement a long time ago. I was making not 3D printed model roller coasters, but ones that you'd assemble with like PVC pipe, balsa wood, using super glue, hot glue, anything I could find. And none of them ever worked. I wanted to actually make models that would function, where you could see, the train run around the track, or have it have mechanical features. And it never worked. Never did. And I was always trying to struggle, like, why can't I get this to work? I've seen other people make these models and they're cool and whatnot, but I never got it actually working. Well, I was thinking I needed to take the human element out of the design process and actually use, CAD software. So you can see these were from over a decade ago when I was playing around building these. So I was like, well, why don't I design these in SolidWorks? And I had a lot of downtime when I was getting my master's degree, where Purdue was like, here's SolidWorks, you can use it for whatever your classes are asking you to do it, design work for. And I was like, I don't really have classes I need it, but I have an interest in actually designing stuff. So I was particularly interested in designing a model of a ride, an actual ride, and I picked in Vertigo, which you see here. This is the actual ride. Kings Island in Cincinnati, Ohio, where I was like, I'm going to model this and I'm going to do it in SolidWorks and 3D print this thing. Well, the reason I picked this is because it's a small layout. It's a boomerang coaster where I don't know if you know much about roller coasters, but it kind of goes up the lift and it drops you and you go through the whole course. You go up another lift and then it'll drop you again. And so I was like, this is a small enough footprint that I could, build this. And I tried to design it around a 4 foot by 8 foot table, like a sheet of plywood. So that was kind of the constraints. I was like, all right, let's go forward with it. Well, one of the cool things about the design process is I actually use another program called No Limits Roller Coaster Simulator. And this is an actual software you can get and you design roller coasters. And the best part about after you design your roller coasters in this program, you can actually go and ride the ride as you design it, which is a lot of fun. And you'd say, yeah, this is a cool game. And it actually is a video game where you can go and ride your rides. However, in the industry, in the actual roller coaster industry, they will make the proposals in this software and then later go on and tweak it. I'm not sure if the video is streaming well, but I hope you get the idea that, we're actually riding the ride. So it's a cool game. But within the game, there's a lot of cool functionality. Let me show you. What you can do within the game is you can export all the spline data for the center spine, the 2 rails that the track runs on, and it'll export it into an Excel sheet. And you say, for example, every foot, I want to know the coordinates of the spine. I want to know the coordinates of the rails, and you can import that into SolidWorks using the curve features. Just saying, I want to import, the left rail, the right rail, and the center. And then you can see what you get right here is the actual layout of the roller coaster that you've designed. So what I would do is start with the center line, which is the blue line on the left, and then I would put the rails in, which is the blue lines on the right. And you have a skeleton for the ride. And then everything from here on out is done in SolidWorks to design the layout. So I would then design the actual track in SolidWorks and design all of the joints that would mount the track pieces together, because I wanted to design it just like a real roller coaster would be designed in track sections that you then use little M3 fasteners to screw all together. So after a lot of design iteration, we were able to come up with what you see here on the right, which is the ride model designed in SolidWorks. And it was designed so you could go and 3D print it. And I got a bunch of cool little pictures showing off the layout and everything. And I felt, really happy with it. I had to go design the trains. So the train was probably the hardest part of the whole process because I had to make sure it would actually operate and function just like a real roller coaster. And I even had a mechanical device in there that you can basically hit with a servo motor, and it would actually open the restraints and everything. So there's a lot of fine tuning and tweaking here. And this was the station with the actual trains on it. And here's a render just to show, the coolness of it, I guess. It is just cool with me, at least. So that was the process to go from a computer game of a roller coaster simulator, and you can actually design based off that layout and use SolidWorks to create a physical model. And everything you've seen right now is just digital. So let's actually go build this thing. So what I did is I started 3D printing the parts. There's over 33 track sections. I have multiple 3D printers in my house, so I would kick them off, and I was actually using scrap material at the time, just of all the other projects I had going on. So printed all the parts, then I painted all the parts, and then I put it all together, and what you see here is the final version of the ride that was 3D printed based off a computer game using SolidWorks to design. And the best part is that it actually worked. So I hope this video works. Maybe I can talk over the sound effects. But as you can see, this is all 3D printed, designed in SolidWorks, and it actually functions just like the real ride.
Matt, that's awesome, man.
Thank you.
That is cool. Wow.
Very cool.
Can I ask a quick question?
Absolutely.
How did you know where to split off the tracks? Was it based on the bed size and availability for your 3D printer? I saw you showed you had all the different track sections.
It was definitely 3D printer based, not so much trying to be, resembling the real ride. Because in the real ride, they split up the track section. This was specifically for a Lulzbot 3D printer, which has a bed size of like roughly 11 by 11 inches. So I think the track pieces I'd have to go and measure them, but I think they're like 10 inches long, 11 max.
Gotcha.
And there was a lot of, I'm kind of skipping through a lot of the learning, but you'll notice the actual rails on this, it's actually butyrate tubing. It's not 3D printed material because the 3D printed rails were too rough. And after sanding for hours, I was like, this isn't going to work. So I had to switch to butyrate tubing, and it worked beautifully.
So how did you get just real quick, how did you get the details for the actual roller? Was it loaded into the game, that roller coaster, or how did you?
Let me see if I can go back. The action, so, okay, not going too far into the weeds, but you can go to Google Maps, take a snapshot, and actually, if you download Google Earth, you can actually get all the measurements. You take a top-down view of it, then you can import that into No Limits and trace the Google Maps.
Wow.
And if you go to Wikipedia and the rollercoasterdatabase.com, they'll tell you the height of the loop, the height of the Copa roll, which is, you know, like the elements of it, and it'll tell you the total height. And basically knowing that and having the Google image, you can design the whole thing very accurately.
Okay.
I'm not going to say it's perfect. It's close.
That's like a whole new level of reverse engineering, man. That's awesome.
Well, you know what's funny is I'm going to kind of get into the weeds a little bit more of where this journey is taking me. This is the first model I did, and there's a lot more to go. And I'm skipping over a lot because I don't want to take up your whole day, but I want to just show you some of the cool stuff I've done with Solidworks and not just Solidworks, but the community that I met. Like obviously I met Kirby through some of the stuff that I've been doing. And you know what, you find out certain things. Like one of the things I did learn is when roller coaster companies are coming up with these proposals, they'll actually use No Limit Simulator because it's so real, and they can actually sell their product to the customers. And there's so much under the hood that you can do with the program. For example, I exported the spines and like the data, but you can not only export the layout data, you can export G-forces, lateral forces, vertical, all the mathematics. You can actually simulate your own mathematics. Let's say I want to have gravity twice as like 2 Gs instead of normal gravity. You can simulate that because it's a simulator. So there's a lot of other cool things that you can do. And what I found out is after I got more connected with the amusement industry, they were telling me, oh yeah, we use the software a lot. Actually, we'll use it so much, we'll design the whole ride, then ship it off to another engineering company that will then run their own formulas to ensure that we're not going to be exerting too much force on the riders. So it's actually very interesting that they're using this technology.
How much is the game?
For the actual game, it's like 20. But if you want the professional version that gives you all this functionality, it's about 150 to 200 bucks. And it's a one-time purchase, so it's really cheap, which is also very nice. So I'm gonna skip a little bit ahead of where I've gone with this. But I posted online, and I got some traction with people being interested, saying like, "Hey, can you build bigger models? Can you build models for parks?" And I didn't say no. So there's a amusement park in Sandusky, Ohio. It's called Cedar Point, and they had a new ride come out in 2018 called Steel Vengeance, and they asked me to build a model for them. And as you can see, it was huge. That's me working on the model at the park. The actual model is 28 feet long, 18 feet wide, and from the ground height, I think it's 7.5 feet tall, and I'm 6 foot tall. So once it's on the table, the hill's almost, I think it's like 5'8", I think it's just under there, but it's huge. And we went back and forth with the park on what they wanted. I was saying I wanted to be bigger because to get the physics right, it's easier to use a larger model. But it was just so big. The constraint here was I had to be able to fit the model through the front door. So we landed on the size that it's at right now. And I had to recruit my wife. This whole model was designed in SolidWorks. And I had to design every bent, and the bent is what I'm gluing here on the top left. We had to glue every individual stick on this ride, but every bent had a drawing. And what I did is I went through SolidWorks, designed all the bents, then we had a drawing per bent, and I would glue it up, and then my wife on the right there, she would glue them to the table. So we had kind of a process going, and even with that, I think between the two of us, we have logged over 2,500 hours on this entire model. And the cool thing is we also put LED lights on it, so it lit up at night. So that was a lot of fun. My computer didn't like me every time I loaded this thing because it just get bogged down with the large assembly file. So that was a whole challenge of itself. And right at the end, or in the middle of creating this model, I was in I don't know at what point it was, but at the same time, I was in the conversation with SolidWorks and the community there. I was always talking with Rachel York. She has been definitely an influence on me on the SolidWorks community and just trying to get involved. She's like, you need to come to SolidWorks World. And I was like, oh, what is SolidWorks World? And she was like, how do you not know? How do you use SolidWorks and not know? And I was like, I don't know, I got a lot going on. So she invited me to come and share my work at SolidWorks World 2019. And I actually assembled another model, which was Batman from Six Flags Great America. And they had me present where I was at in my journey to that crowd. So everything up until about now, I've presented at SolidWorks World 2019. And everything that we're going to talk about after this is kind of new and exciting. And you guys will be really the first crowd to even know where I'm at. So that's kind of exciting too. So I was at SolidWorks World 2019 talking about how I use SolidWorks to design miniature model roller coasters using 3D printers. And I absolutely love that experience. And after that, I actually got contacted by a toy company that makes working model roller coasters. And you can look them up, it's Coaster Dynamics. And they were struggling to come out with product because their engineering department was just 2 guys. And they said, hey, could we ask you to do some of our design work and see if, you could, pick up some of the work that, we just can't pick up. And essentially they were saying, can we just contract you to do some of the design work? And I was like, absolutely. So here's a couple of the actual products that I have designed also in SolidWorks for them. And they just go off and manufacture it. And I know this is the London Usergroup and the top right here. These are static models of roller coasters. This is of Nemesis at Alton Towers, and that's the United Kingdom. So that's kind of cool. But essentially, the parks would contact them, and they would say, we want a static model of this ride. And the company was like, Matt, you know a lot about roller coasters. This should be easy for you. So I started designing these nano coasters for them that you can order on their website, and also you can find in amusement parks. In addition, they had their Lego compatible roller coaster, which actually does work too. And they were asking if I could mimic actual roller coaster trains and see if I could capture the theming in their toy. So this is Lightning Rod. And what I did is I designed this in SolidWorks to mate onto their compatible roller coaster train. And they're like, do you think you can actually capture this and make it look good and make it so we can 3D print? I'm like, I can get close. And I thought I did. I got close enough to make them happy at how small it is, because it's a little Lego train. So that was what came out of SolidWorks World 2019. I got to meet up with these guys, did some work for them, but then I kind of went back to my roots of like, I want to design better roller coaster models. And now what I did is I went a different route where now I'm going to design these trains based off roller coasters. I want to see how much detail I can pack in there with 3D printing. So this is a model of Raptor from Cedar Point. This is the actual ride in the top left. The bottom left is just a render from SolidWorks. And then the right here is actually the 3D printed version of it that came out of from SolidWorks. And the front train there was printed on a Formlabs 3D printer. So it's like the resin 3D printer. It just came out beautiful. And I think it looks almost identical to the real thing. And I had not much to work off of other than pictures online and just kind of going off of, human proportioning and all that. So I started going into this, making almost like model cars, but like model roller coaster trains, and seeing if I could get a manufacturer interested and seeing if they could have these for their trade shows. And then I did another one based off Orion at Kings Island, which is in Cincinnati, Ohio. This is just a rendering from the press release, and I designed it also in SolidWorks and 3D printed it out to talk about these train models. So while I'm doing all of this, at the same time, I was promoting the work that I was doing, and I was also just getting feedback from college students. I went to Purdue University, my alma mater, talked about roller coaster design there. I went to the Ohio State. This is at SITE, which is Students in Themed Entertainment. I brought the models to the event and started talking about, what I do, which is also a weird experience because professionally I work at Ford and automotive. this is just a hobby. And there was all these kids asking, you know, can I get a job at your company? Like, this is the coolest thing ever. How do I get involved? And I'm like, I'm just a guy just doing stuff for fun. And I don't even know how to make money off of this yet. I'm just kind of just doing it because it's fun and I enjoy the work. So they really just love that. And I kind of just went with it. And in this great picture here, you can see my little bald head over here in the corner. So that's me, which is a lot of fun. So then more recently, I was invited back to go to 3D Experience World back in February. And due to the awesome community that Solidworks has, I was introduced to the folks at Formlabs, and they actually had a booth at the event, and they asked me if they could showcase one of the trains. And I was like, well, this is great, because actually 80% of the parts are printed on your Form 3 machine. And they had at their booth one of my trains. And I think actually Rachel York at the time was like, wait, they get a train? I want a train. So then in the Hive, she had her own, and that was the Raptor train that I've been kind of touring along with. So she got a train there as well. So I had 2 models at 3D Experience World, and I got a lot of great feedback of like, these are cool. And like the biggest feedback was, you know, this is cool. Where do I get one? How do I buy it? This is awesome. And the cool thing about 3D Experience World is this isn't even roller coaster people. This is engineers and designers, and they thought it was cool, which kind of, you know, maybe sit back and think, well, if they want it, why wouldn't other people want it? The problem though is with these 3D printed models, like the Raptor one, for example, has, you know, over 7 cars. There's all the 3D printing. Then there's the labor. Then there's the hardware. And I think alone, and what I try to do is I offer the CAD files up for anyone to download online. All these people to download it and then give me a 1-star rating because they're like, yeah, it's a cool model. However, you need to go buy $300 worth of fasteners from McMaster-Carr to go and put this thing together. And the roller coaster enthusiasts are all like, you know, between the ages of like 10 and like 18, so they don't really have money anyways. And they all got they like just gave me 1-star reviews. And I'm like, nah, this sucks. I can't build it. And I was like really bummed out about that. So, but the cool thing was I took this to 3D Experience World, and everyone was saying like, oh, can I get one? Can I buy one? And that was like the #1 comment is like, would you ever have a roller coaster train product for sale? And I was like, well, I can't find the price point that people want, because, and that's not even talking about all the time it takes to design and engineer these and to make them go together. This is just material cost, and then not even including assembly and then distribution. And like I was thinking like, yeah, you could probably buy one for $1,000. No one's gonna want that. It wasn't feasible. So it was actually at 3D Experience World. It was in the middle of the week. I was like, well, there's gotta be a way to do this. So I was talking around with a bunch of like the people I knew there, and they're like, well, why don't you just go and laser cut one of these things? And I was like, laser cut? Well, the material's cheap, but how do you capture the embodiment of a roller coaster train in, you know, a laser cut thing? So what I did is once I got home, I went and bought a laser cutter. So it was a busted up one. This is actually my brother. He was helping me move everything around. I was very excited. So I bought a laser cutter, and then I went back, and you can kind of see I redesigned all of the trains that I have done in a manner that you could laser cut in a 2D form and put it together. One of the other constraints is if you want to put this together, you don't want to have fasteners per se, and you don't want to have glue. So as you can see in one of these pictures is I tried all sorts of different tabs. Like, I don't know if you've heard of like U-Gears or Rocker, or all these laser cut companies are just coming out of the woodwork, pun intended, that they're selling these cool toys. And I was like, well, why can't I just do the same thing? We have little tabs where you kind of assemble train models, and then you could sell those to the parks as a souvenir, or you could just sell them online and kind of capture the emotional connection that people have with these rides. So I had to go back and redesign all of them. This is kind of just like a time lapse of all the design work. And as you can see, it's in SolidWorks, which is awesome. Can't mention that enough. And we created or designed laser cut roller coaster trains that you could assemble yourself. And the idea is it could be a souvenir at a park. And the best part about this, the material cost for what you see here is about 25 cents. It is 1/8 birch plywood, and it is dirt cheap. The actual time is just the labor to watch the laser cutter to ensure it doesn't light your house on fire. So what I did is I just started going and laser cutting all these new trains. And there was lots. Sorry.
Burnt edges are the burnt edges are super cool too. How it's kind of like they're a little bit charred.
Absolutely. It adds like another
Yeah,
like depth layer to it. I
that's
can't
cool.
explain it. I do like it though. It is awesome.
It
And
gives it
you
more
can probably see
character.
it better here. Sorry?
It gives it much more character.
Yeah.
Yes.
Manufacturing process, it's like sketching as compared to a photograph. It just got the personality behind it.
Absolutely. And you can do cool things with burnt edges. For example, like in this example right here, this is based off of a ride at Busch Gardens. It's called a dive coaster. But I put it on the model and you really can't see it until the very end. And what I do is you can raster or basically burn in images. So what we did is you can put the name of the park and the name of the ride onto like the base, and it just looks really cool that you can basically essentially burn in other features into the model. And then these are just some of the other ones that we've been doing. Just the cool thing is you can make one train design and then just change the logo, and you're already marketing different parks with different rides, even though there was only the original design. So you try to be smart with how you design the models based off of different roller coasters that have multiple iterations throughout the world. And here's some more. This is a Timberliner, one of the newer Iron Gwazi models that's in Florida, and then the Beast from Kings Island. I kind of went a little crazy when I realized I was onto something. I tried to design everything essentially and laser cut as many samples as possible. And the goal seriously stemmed from 3D Experience World this year. Like, this is actually very recent, where I took this 3D printed train and everyone asked me how they could get one or something similar, but not at the same price point as a 3D printed train. And you can see that I still was able to capture the essence of that ride vehicle in laser cut birch plywood. So that was the goal, and I think I nailed it, especially with the amount of detail you can get. As long as you really just sit down and understand the train and what you're trying to copy, you can really do some cool things. These are actually some trains, the full train on a track display stand that we were looking into, that you could display. They're a little big. I don't know if you'd want to put on your mantle out. Like, my wife won't let me put one on a mantle, even though I'm gonna just sneakily put it there someday.
Have
But yeah,
have you thought of using like acrylic to add color to it as well?
absolutely. So that's another thing that's come up a lot, is either acrylic, or you could screen print the wood and then cut it. You basically have a jig. You screen print the color, or you could paint it on the wood and then cut it. As far as acrylic goes, I've thought about that too. I haven't tried it yet because I have to get the different colors. Then it would come down to a price point of, would people want to pay for an acrylic or a wooden model? So I've thought about it. We haven't done it yet though, but I will consider it since you brought it up again.
Hello.
And this is, I'm sorry.
Hello.
Yes.
Yeah, that's congratulations, Matt. That's a very good effort. Actually, though, the technology is new to us in Nigeria. I mean, the 3D printing.
Mhm.
But some of us have ideas as to, the importance of that. I wanted to know, which material actually did you use to print that your roller coaster? Which material was it? Resin or metal?
It is, we use just the hobby grade 3D printers that use PLA or ABS plastic.
Okay.
I haven't used the metal printer. I think the most exotic material I've used is from the Formlabs resin printer, which uses their forgot what it's called. It's their pro gray resin. So that would be the most exotic material I've ever used. And with the SLA machines, you can get really highly detailed parts for a low price point.
That's great.
Thank you. And so, yeah, that's kind of like where I'm at. So right now we are developing these coaster train models for parks and seeing if anyone will bite. I'm not going to say who has. I've thrown a lot of models out here. These are all examples that we've done them or gone to market and see if anyone would be interested in. And I'll just put it this way: there's a lot of interest, more so than I was. I'm kind of overwhelmed with the interest in these as just souvenirs. So I'm hoping next year I can come back saying I actually have orders, I actually have a product, and really the idea I like to just say and contributed to just being at 3D Experience World, where I had engineers and designers saying, hey, you got something cool here, have you ever taken it to the next level? And that's really what I wanted to at least talk about today, is like what cool things you can do. And then the last thing I want to say just to finish this is I like to have a lot of fun with this. And I was thinking, I'm like, well, if you laser cut 1/8 inch plywood, what if you could blow this up and cut it all out on like 1 inch thick plywood? And so I went and did that, and then you can get these huge ones, which I only did it for the cool factor. So that model is made on 1 inch plywood that I had to get a CNC router to make. And the actual wood on the platform that you see there is over 200 pounds. So I can't even lift it myself. I had to put it on a dolly.
Maybe if you use marine ply, you could turn out children's playground stuff.
Absolutely. Absolutely. We were kind of thinking of, making one just like, this isn't a 1-to-1. This is, I think, just undersized. It's like 3/4 scale. So I can't even really fit in it. But if you made it big enough, you can make a display stand that kids could sit in and get their picture on or something. I don't know.
Yeah. Well, those little rides they put outside shops and McDonald's or whatever for kids to climb on while the parents are either having a meal or filling up the car or something. That would be an ideal place for these sorts of things to sit, and then people would pay to have the kids on them, particularly if they had rockers or some sort of motion that you could fit on them as well.
I'm sure you could just do a little 4-bar linkage, just have it, just kind of sway just like the real ones or something. I'm going to look into that. Thank you for giving me that idea.
That's cool.
Next time I come back, I'm going to have one of these moving, and I'll put like...
Right. You might have to take out insurance as well, though.
Yeah, there's so much liability there. So that's all I had. Thank you, Kirby, for inviting me. Was there any other questions? I'm sorry, I was trying to. There was a lot that was there, so if I missed anything, just let me know.
Actually, I have one thing. So I'm one of those college students that downloaded the files and printed out the Raptor coaster.
Really? Well, awesome.
Yes, I actually have it. So.
That's awesome.
Scale.
That's cool.
However, I did not purchase any hardware for it.
So did you use glue?
All the hardware was 3D printed.
Look at you.
I got all the McMaster Car files, put them all in there, printed them all out with a 0.1 millimeter nozzle, and didn't pay a penny for it.
Oh my gosh. Hopefully there's no McMaster Par representatives on this call, because they'd be like...
Exactly. But,
you've got to remember that students can be misers.
They'll always find a way.
Wonderful.
Well, that's right. It's called ingenuity.
That's nice.
Exactly.
Yeah, thanks for coming through, Matt. Like, when I saw you, I met Matt at Solidworks World 2019, and I saw basically the first half of his presentation there. I was like, I have to tell people about this.
Yeah, thanks for letting me present. Like, I love talking about this stuff.
The virtual meeting, I'm able to get almost anybody I meet at these events to come and present, and don't have to get you out to this side of the world. Although that would be cool to have your model for people to fiddle with. Absolutely. But just hold tight. We're gonna see if we can get some of the laser cut stuff out to Europe too. So there's a lot going on, and I can't talk about a lot of it, which is a bummer. But come next year, I'm sure there'll be a lot more going on. And
Matt, have you ever seen that guy in Denmark who does these creations that walk around on beaches driven by wind?
I probably have. I don't remember the guy's name.
They are fantastic constructions, and in many ways they're as intricate as that very large.
I think they're called Strand Beasts or something.
That Strand Beast, that's it. Yeah, they are just, they look as though they're alive. They have their own minds, and they just set off when the wind takes them and stride off down the beach with him running after them,
I think I've
trying
seen
to keep
that.
them under control later on. But that's the sort of mechanism that really makes people very, very excited when they see it, because
Absolutely.
it's more than animation. You know, it's not AI. These things just work because they're fitted together with joints.
That stuff, and that's the cool thing, like with the working models, is all you have to do is just have it go around once, and everyone's like, "Oh, cool," because it's small. And it kind of works against gravity because it doesn't scale like the real ones. The other thing you don't know is on the real rides, like the train, like the actual individual car will weigh 2,000, 3,000 pounds, and it's like, all right, how do you take like tons of weight and put it into like a little car that big to keep that momentum? It's not trivial. So you basically have to work with what you got, which is friction and momentum or weight. So you try to reduce friction and increase weight as much as possible.
Yeah.
I think Steve has posted a video about the Strong Beast. Yeah.
Wow, I've never seen that before. That's cool.
Yeah, I think
there's,
he actually.
There's a whole variety of them. And they make some lovely noise because the wind on the structure and the movement just creates its own little noises.
He was actually he actually spoke at World 5 or 6 years ago.
Really?
Yeah. It was very cool.
Yeah,
I think
you get a lot of
people they're made out of small PVC tubing, you know, as used by electricians or plumbers or whatever.
Yeah, you can buy little wooden models that you can build together, so little kits. Yeah, they're quite popular now. I think Adam Savage did a whole video about it.
Oh yeah, he tried to build one at like Maker Faire or something, I think.
Yeah. So they're pretty cool. Matt, one of your roller coasters on top of that. But yeah, thank you for coming through. Thanks.
Yeah, thanks.
Yeah, it was
Thank
awesome,
you
man.
to Todd and Steve for showing us some cool things to do with Solidworks. I mean, I learned quite a lot about mates in there as well, which is quite interesting.
It's always something small you can pick up, right?
Yeah, like I know I've had a lot of problems with like group projects of trying to get things together when you need parts from someone and you got to wait for them to finish on it or something like that. So it's using the cloud can help out quite a bit. And mass roller coasters are just awesome. Yep.
Something that Steve didn't go on with after he'd created his X-shape thing was what happens when you bring that into SolidWorks and then do other things to it, like putting in cuts and details and stuff. Can it go back into X-shape and have the main body modified? Is it all history based in the same way?
So you can bring it into SolidWorks. It'll show up. So if Todd were to open that assembly, it'll have the foot that I designed, and you know, you can, common use would be like, okay, I'm going to build out my actual, you know, clips or mounts or whatever the mechanical features are.
Yep.
Those won't push back to X design, but any modifications you make in X shape will push back into SolidWorks. So it's
effectively they re-import into the detailed version.
Yeah, there's this concept of CAD mastership on the platform. So whatever tool created the geometry effectively owns the core creation of it, but the other tools can add to it, if you will, if that makes sense.
Okay. Right, thank you.
Mm-hmm.
May I ask one more question, Steve, to you? The body you work like a clay job. Will it be transferred as a solid body when we open the assembly or a part file in SolidWorks?
Yep, it'll be a solid body inside of contained in a part file.
I have one question about when you are creating or modifying, pulling and pushing the clay box. Is it possible, or is there any settings to define the minimum radius, curvature radius, not to modify too much? Because after making some kind of these designs, as Dan knows also, we need to choose the minimum diameter of the milling tool. So when I am modifying the bodies for foundry products, I'm always keeping the minimum curvature radius that we can make the actual milling.
So I don't.
Is there any option?
Todd, you can correct me if I'm wrong, but I don't believe there is right now.
No, Unfortunately, we don't. You'd have to, it would be a little trial and error, I guess. You'd bring it into Solidworks, use the minimum radius of curvature check tool to see if you had any of the situations, modify it in X shape, update in SolidWorks, and look at it again. Unfortunately, that tool is not there yet. But one thing I'd like to point out is these 3D experience tools like XDesign, XShape, etc. on the platform, we're putting out a new release almost every 3 months, or an updated release. So they're in a very rapid development cycle. And one of the reasons we're able to do that is because at Dassault, what is it like? More than 50% of our employees are R&D. We have a huge, enormous R&D staff. So being under that umbrella, there's multiple, matter of fact, the XDesign, XShape tools are developed not just by SolidWorks, but we also have developers from the CATIA brand working as well, working all together under one main umbrella. So, stuff like that's being added very rapid succession.
Thank you.
I think that's a good point to leave it there. I've recorded this. I'm going to figure out where I'm going to put it and when. But if you register the meetup group, that's probably where I'll post a link to it. If anyone has some cool stories to share or has some really cool tips and techniques that wants to present at my next meeting, don't hesitate to email me. Or if you've got any questions about something technical, you can email me and I can try and find the answer for you. If I don't have it, I can try and find someone that will. But thank you very much for attending. Thank you,
Kirby.
Everybody that
Yeah, Kirby.
Thanks,
presented
Kirby.
that.
Meeting. Thanks, guys.
That was
Everybody.
Many
good.
thanks to all the
Thanks,
guys who
everybody.
presented.
Yeah, thank you very much.
And
Yes.
thanks to you too, Kirby, for organising it all.
See you, everybody.
No problem. Thank
Awesome
you.
meeting.
See
Cheers.
you later.
Yes.
Cheers now. Kirby, are you still around?
Yes.
Is it I've been getting emails recently from your printing company about the new materials and things that you're running, and I was wondering how it is possible to get hold of some flexible feeler samples for the SLM.
If you go to, I'm not sure which page it is at, but you can request a sample pack. In our sample pack, we're putting a little example of shot peen and the SLS nylon. We're busy messing around with MJF at the moment now.
Of course, yeah, they've got a flexible as well, haven't they?
Yeah, we're using just nylon 12 just while we have it, but we've just launched the MJF. That's the big HP machine. We've launched that on Friday, so we're doing that now as well.
Oh, that's good. I've looked at the MJF stuff at exhibitions with one or two of the people running them at TCT and things like that, and